Alright class, so today we're under week 24. We're going through our notes, electromagnetic wave interactions. As a friendly reminder, we have our objectives up on the board. We've already been through them. We've already done our lab, and now we're going to go through our notes about that lab. So you can follow along in Google Classroom, and Sam, I'm going to pass out our Spanish guide so that you can follow along in English and Spanish. As we're going through, you're going to see that there's keywords that are bolded and underlined, and they're segmented by bullets. Make sure you're focusing on those so you can fill in the blanks as we're going through our notes. So, we're going to start with visible light. Visible light is a part of the spectrum on the electromagnetic spectrum. It's the only one, as the name implies, that we can see. You can see the spectrum is quite long, but that visible light is a tiny little segment of it. And we're working with visible light today because you can interact with it easier than something like a gamma ray, which will unfortunately be lethal. So, in this object, we have a prism. I'm going to ask you to all come up and get a prism. Prism is just like a triangle, essentially, that's been elongated. And we are going to learn about the word refraction right now. Refraction. Refraction. Go ahead and stand. And we have our flashlight. So your goal is to try and angle it in such a way to where it'll shine off and make a rainbow. You can see it's easiest to do on the edges, but why don't you two go ahead. I suppose we can work as a group and see what you can do. I want to go ahead and turn both the lights off so we can better see it though. If you are having a hard time making a rainbow, you can see it in there. And as well, I've already gone ahead and I made a pretty awesome one using the sun. The sun has a much stronger light, so you're able to get a better rainbow. Luke, are you able to get yourself a rainbow? Yeah. Why don't you go ahead and let Maya try that. Maya, can see if you can't make a rainbow. You able to get one? Mm-hmm. Sweet. So we just experienced there, class. Refraction. Refraction. You slow the light down, and it breaks up into the individual wavelengths. And each of those wavelengths have a different color. We can use the acronym to help us remember. Roy, G, Biv. Red, orange, yellow, green, blue. Indigo, which is like a bluish purple, and then violet, which is just purple. So, what did we experience right here, class? When we split light, when we bend light? Refraction. Okay. Any questions about that? Okay. So, we saw the rainbow. It splits it up based on the frequencies. And there are some relationships that we know. Red has the shortest frequency, which in contrast is at the longest wavelength. Violet is the opposite. So if red has the longest wavelength, what's violet's wavelength like? The shortest wavelength. And if red has the shortest frequency, then what's violet's frequency like? The highest frequency. Wonderful. Now, when you combine all the colors together, it makes white light. And what you just did with your prism proves that. So scientists took this white light that we're producing here, and they figured out it was made out of the rainbow because we can see it break into its individual components. In a fancy enough experiment, you could have that rainbow then go back into a prism and go back into a beam of white light. It's reversible in that way. So we've talked a little bit about colors and how we can see them. But I want to pause for a moment, and I want you to have a chance to think about this. There are three objects on the screen, and there are two ways in which we can see them. I'll let you know that these, the light from the candle and the light from the sun, is the first way, and the moon is the second way. Luke, you have been through my class before. Could you refresh our memory on why the candle and the sun are visible? They make their own light. Maya, you're a bright gal. Does the moon make its own light, do you know?
No.
No. How come we can see the moon then?
The light of the sun reflects on it.
Bingo. The light reflects. Our second vocabulary word. First, we had what? What did the prisms do for you? Refract. And why can I see the moon? Reflect. It reflects the sun's light. And these are the only ways you can see something. It either produces light or reflects light. You can see it gives you some other examples. Things like the sun, the candle, the flashlight. Can you think of anything else that makes light? A light bulb. Good. Maya? My favorite's in 4th of July. What makes light in 4th of July? That's one of my favorite light producers. And then reflects things. We did an example of moon, mirror, or glasses. Let's ask a question. Can you see your reflection a little bit off of your tabletops?
Soto girl, the office for dismissal, please. Soto girls.
Yeah. So, many things can reflect light. It doesn't have to be just like a mirror. And so, with that, we can do a test to learn about these 3 vocabulary words. Opaque. Please say it after me. Opaque. Transparent. Transparent.
Transparent.
And translucent. Translucent.
Translucent.
Great. The easiest way to figure this out is the flashlight test. Let's start with opaque. Take a flashlight, it's turned on.
Danielle Williams,
Put it
office
under
for
an
dismissal,
object.
please. Danielle
If
Williams.
it does not shine through, it's opaque. Is the table opaque? What else is opaque in this room? Go do the flashlight test on it. Your arm can be opaque. One more thing, please. Maya, what's opaque in this room? What will light not pass through? Bingo! The frog is opaque. Good job, you two. Let's move on to the next item. Transparent. You've probably heard this word before. Could you tell me what it means or an example of it in this room? Light can go through it. Could you give us an example of something you think light would pass through without any issues?
Good glass.
Yeah, glass, or like the glass in the prism. The glass here, maybe you have glasses, or the light that's shining over the plastic that covers. Transparent means there is no problem with light passing through. So, I'm going to take the flashlight, and if this glass is not transparent, I shouldn't be able to shine the light in your face. There we are. Is it transparent? Yeah. Okay. Lastly, translucent. Translucent. So we said opaque lets all light no light pass through. Transparent lets all light pass through. What do you think translucent is? It lets some light pass through. Good. And a lot of people think of like frosted glass or something like that, and that's okay. One of the easiest demonstrations I have is this hand sanitizer bottle. You can see light can pass through. I'm able to make light show up on the ceiling, but it's clearly not passing through unabated. It's getting diffused throughout the bottle, causing it to glow rather than just shine straight through. Does that make sense, everyone? Okay. So what we're going to do is we're going to pretend like we paused, gave you some time to think, pair, share, and come up with 2 examples for each of those. Afterwards, I would ask you a question like, air, the stuff I'm waving my arms through, is it opaque, translucent, or transparent? It is transparent. Why is it transparent? Because you can see through it. Light can pass through it without any problems. So what I want you to pay attention to is what's known as the law of reflection. we're going to shine the light at a 45-degree angle. And the incidence ray, the thing that comes off, you're going to see is hopefully at an equal but opposite angle. If I increase the steepness of the angle, you see it increases the steepness of the output. If I have it going straight up and if I have it going straight down, it's going to try to go straight up. This is known as the law of reflection. You'll have an equal but opposite angle come off. And you can see that in our notes as well. You have the incident ray and the reflection ray. You can see they're both at 45 degrees, just like you saw in your lab. Okay. Refraction. Where have we already seen refraction, class? Say again? Well, we're going to get to this. Where have you already experienced refraction? We haven't done this yet.
No, it's like a straw in a cup.
Yep, on a straw in a cup, you would have the same experience. You've seen refraction as well with the prisms. So I want you to take a moment. I want you to look at your beakers and look at how the bottom of the writing utensil appears different than the top. Maya, could you share what the difference is that you see?
It looks bigger.
It looks bigger. Good. Is there anything else weird?
The end looks like it's kind of.
Like separated, right? Good. What you're experiencing there, refraction, to bend light. You can bend things small, you can bend things big. In this case, did we make it bigger or smaller? Made it bigger. Now, I want to show you something. This is how telescopes and eyeglasses and all sorts of technology works. And I'm going to give you two shapes of lenses. One that is convex and one that is concave. Come on over. Go ahead, take out your lenses. And you can go ahead and take a peek through them. You might need to adjust your focal length and tell me if it makes things smaller or bigger. Smaller. What about yours, Lou? Bigger. Let's go ahead and trade. Y'all two can trade. Does yours really make it bigger? Try that. It looks so much smaller, Lou. Bigger or smaller for that one? Right? What about yours, Luke? Might need to adjust the focal length. So what I want you to focus on is these images right here. The red lines approaching the eyepieces is light. And with the convex one, when light hits it, it'll bring it to that nice point. Conversely, the concave one, you can see it's shooting the light off in different directions. It's causing it to bend or refract. And depending on what shape the light is passing through, we could either see it come to a focal point or we could see it spread out, making the image look big or small. So what tool do scientists have that you think would bend light, refract light to make small things look big? What are you looking at in a telescope? A microscope. Good. So in this case, we can see we're going to take a small image and we're going to make it bigger. So you would use that lens for a microscope. And you already hit the nail on the head. We might need to collect light and bring it to a finite point using a telescope so that we can better perceive it. In class, what is this? We're bending light. What's the vocabulary? Refraction. I think we're probably going to pause there, guys. Let's see.